One of my favorite sections, meteoroids. Here we go. First of all, what is a meteoroid versus, let's say, an asteroid? Well, there's not a really great distinction. They're both just rocks flying around in space. Roughly speaking, if it's smaller than a football field in size, we would tend to call it a meteoroid, and anything larger, an asteroid. Doesn't really matter. But there are three terms that you need to know to speak fluently on the subject, and that would be the difference between a meteoroid, a meteor, and a meteorite. So a meteoroid is basically when the rock is in space. A meteor is when it's coming through the atmosphere, and actually it doesn't matter what it is, whether it's a meteoroid, it could be a part of a satellite, it could be a comet, but anything streaking through our atmosphere, and it actually forms so much heat around it, you're forming a plasma around it that's lighting up like that, and we call that a meteor, or the common term, shooting star. So another really terrible term, since it has nothing to do with shooting stars. The typical quote-unquote shooting star is actually about like a grain of sand that's coming through our atmosphere at a tremendous speed and producing that plasma around it. So, and it's only, a few miles up, really above your head. So it has nothing to do with stars whatsoever. And then if any piece of it makes the ground, which is actually rare, percentage-wise, a very small amount would actually, if it's the size of a pebble or a grain of sand, it's just going to completely disintegrate. But if it starts large enough, maybe the size of a beach ball or something like that, and part of it survives, we call it a meteorite. So any part that makes the ground is a meteorite. I tried to do some research on this. It looks like about 4,000 meteorites land on the Earth each year. Of course, about 3,000 of those would land in the oceans. So we're only looking at 1,000 spread out over the entire land surface of the Earth. Now, I want to share a quick story with you. The first time I ever took my students out for what we call astronomy night, it was kind of a boring night, and I really didn't know what I was talking about much at that point. And we were just kind of out surveying the sky, see if we could learn some constellations. There wasn't a meteor shower or anything like that. We were just out there hanging out. And about the time we were leaving, got in my car and hadn't driven, just a few feet, and there was this streak of light over my car. It looked like it was going to land on our school. I will never forget that in my entire life. It was still to this day the most impressive meteor I have ever seen. Here's what it looked like. Yeah. That's called a bolide. When you have a true fireball, it's called a bolide. It's the only true bolide I've ever seen. And here it was on the first time. That was 20 years ago. And I've still never seen anything that cool again. I don't know. And I stopped the car and I heard the kids screaming and yelling. They were going nuts. It was amazing. So anyway, the second best one I've ever seen looks something like this. This was another astronomy night we were having. And it was one of the later ones we did. It was about 1 in the morning at a meteor shower, and we had one that was long-lasting, and it was breaking up into pieces. And that was an amazing one as well to see. It's probably the second best one I've seen. All right, some other pictures that people have taken, bolides and other. Here's that one that was mentioned earlier, the Great Daylight Fireball, Wyoming, 1972. There it is in the sky above Wyoming. Missing by a matter of seconds or minutes, destroying that part of the country. So that was a really, really close flyby. When you see it in the sky, that's pretty amazingly close. Beautiful, beautiful, beautiful. Here was one. Let's see if this is going to play or not. This is from a dash cam in Canada. Look at that, a police dash cam catching that one coming down. Clearly, starting in the 1990s or so, you started having a lot more sightings because video cameras were a lot more prevalent, and you started getting a lot more videos like this. And then 2013. In the town of Chelyabinsk, Russia. Lots of amazing videos of this. Let me skip ahead to some here. We'll get back to some of that in a bit. Here we go. Here are some highlights here. February 15th, 2013. driving. Look at that in the sky. Just amazing stuff. And yes, there was a meteorite from this, and yes, we'll see it. Now, that's all from the shock wave, created, of course. Look at that. Oddly enough, the last time Earth was hit with one that we know of that was this size and power and even more powerful was also in Russia. It was in Siberia back in 1908. We'll talk about that in a minute. Really amazing stuff. Oh, I just had a little joke here. The truth comes out. There you go. That's all right. Anyway, as mentioned before, comets leave a trail of debris around the sun. They actually disintegrate. I'd mentioned that Halley's Comet's good for about 5,000 more orbits, they think. Now, these little pieces of sand, sort of these micrometeoroids, are spread out in this path. I remember when I first started teaching, wondering how we knew that there would always be a meteor shower, in August, and always the Leonids in November, and the Geminids in December. How would we know that? Well, I was thinking about rocks traveling and hitting the Earth. But what I should have been thinking is of the Earth going into the path of the rocks. That's why it's cyclical. So it's based on our orbit going into these dirty debris trails left behind by comets. That's how we know exactly when we're going into one. If we hit a particularly dense patch of those little micrometeoroids, we're going to have a really epic meteor shower. All right. So I mentioned some of the more well-known ones there. The Perseids in August, right around the start of school. We usually go out for the Leonids in November and the Geminids in December. But just about every month has some kind of meteor shower associated with it. These are just some of the better ones.
Most meteors come from random directions in the sky. But during a meteor shower, they come from a particular direction. For example, during the August meteor shower, the meteors come from a direction in the sky toward the constellation Perseus. Their direction is set by a combination of the motion of the Earth and the cometary debris creating the shower.
So it's the Earth heading towards that constellation. That's why they appear to come from that direction. Based on, it's kind of like driving your car into a bunch of bugs in the highway at night, and you see the bugs flying towards your car. Well, that's from the motion of your car. It's not from bugs just all of a sudden flying at you. That's from your motion into them. And so that's the way you can think of a meteor shower. This kind of illustrates the same thing. Here's the Earth, and look at that. We're heading towards Leo. And as we head towards Leo, we're going to have an increasing number of meteors or shooting stars that night. And it's usually spread out over a few nights, and there's kind of a peak night, and that gets a lot of attention. But just for the record, you can see shooting stars any night of the year. If it's clear enough and dark enough, you can always see shooting stars. Here, when you do these time lapses, you can start to see them converge back. You don't notice it when you're just out in the field or wherever, but over time, you notice that they converge back to a point called the radiant. That's where they come from. These are all long time exposures, I'm sure. All right. So, early in the solar system, everything was getting smacked by asteroids and things running into each other, and chunks of our moon and Mars were thrown out into space, and some of them landed on the Earth. I assume there are probably pieces of the Earth on them as well, which is amazing, but we've actually found pieces of Mars and the moon on the Earth. So this says if it's about a meter wide, I can't quite fit that in the camera screen here, but about a meter wide, it has a chance to survive as a meteorite. And of course, it can make a crater if it's large enough. Which got hit more in the early solar system, you think, the Earth or the moon? Well, clearly the Earth. We have more gravity to suck in those rocks, and frankly, we're just a bigger target. So the Earth, we look at the moon, it's completely covered in craters. Well, the Earth was as well. The Earth got hit just as much, or actually more, and so we have lots of craters, but the one thing we have is erosion. We've had billions of years of wind and water and rain and volcanoes and all that. So, not to mention plants and animals and people. And so our craters are mostly gone, but there are about 100 that we can still see at 170 impact sites. Here are some of them. we can assume they're actually spread out more evenly than this. You notice they're centered around sort of population areas where you have a lot of universities and stuff that would be studying them, so this is a little misleading. So here's an example of a sort of a hidden crater where you have this, you're out there on the boat in this lake, and you don't realize you're in an ancient crater. See how round it is? Here's one where it broke up into two pieces, bam, bam, double tap there on Canada, side by side there, those lakes. And this is my favorite one. This is so cool. This was discovered in 2010, but what was cool about this was it was discovered using Google Earth. Yeah. I've had my students do this before, just search, just see if we can find any craters. And we found a whole lot of interesting ones. We just didn't have a way to verify, so that's pretty neat. The most well-preserved crater on planet Earth is Meteor Crater in Arizona, or Barringer Crater officially. I took my kids there, actually, in the summer of 2017, and was really amazed by it. I should have thrown those pictures in here. I guess I didn't. And why is that one so well preserved? Well, the number one reason, it's young. This impact occurred, I think it was maybe 30,000 years ago, so it's practically brand new, compared to like the craters on the moon you see that are 4 billion years old and change. That makes this one brand new, and it's in the desert, so there's little erosion. I was amazed by it. I just thought it was really a deeper crater, a wider crater than I'd really sort of visualized in my mind. And we were there in a storm. It was really a neat experience. It's a little bit off the beaten path. It's about maybe a 2-hour round trip if you're on your way to the Grand Canyon, which we were. Maybe more than that actually. And but it was worth it. Absolutely worth it. All right. I mentioned earlier that Russia was the last country to be hit. And that was in 2013, but before that, the last well-recorded example was in 1908, which is an even bigger blast called Tunguska, based on the region, the Tunguska River in Siberia, where it hit. Really interesting stuff here. One thing they learned, there was an expedition that went out to try to find the meteorite. Year after year, they went out and never found it. Why? Because it exploded in the sky. That's what we learned from this impact, is that meteors, they come through and the pressure builds in our atmosphere. They can just blow up, and actually it can cause a lot more damage. Just flattened an entire forest in Siberia, and it was only, a third the size of a football field. So that was an amazing. Look at that. That was taken like a decade later. Still just complete damage there in that area. Skip this part, I think. And let's get to meteorites. You see a lot of them can be very, very dense, the ones that are especially made of iron and nickel and stuff like that. Again, we can assume most of them have been around. They're kind of primitive material from the beginning of the solar system. One famous example was the Peekskill meteorite. This was cool for a couple reasons. Number one, lots of people videotaped it, most famously from a football game. This was across the northeast of the United States in prime time, and people had video cameras out, and then amazingly it actually landed in the trunk of somebody's car. There it is on the ground there beside their trunk. You can see what's called the fusion crust on there, where it melted the rock as it came through, so hot. Anyway, it's just crazy. So where would you go to find meteorites? Well, because of that dark fusion crust, go to a place where you have a bunch of white rocks like this, where it would really stand out. Or probably the best place on Earth would be Antarctica, someplace like that where you have all the white ice and snow, and you can really see these things stand out. You go out, plus you get to drive around in a snowmobile, which is lots of fun. All right, pretty cool meteorite here. This meteorite was found on Mars. Yes, I think that's the Curiosity rover there that found that one. A meteorite on Mars, so that's just pretty amazing. And that came again from debris in our solar system. Here's one of the largest ones ever found. Kind of a sad story behind that, how they took that from some people. And then another huge one there, one of the largest ones right there. And I think this is, from what I can tell, the largest single meteorite on Earth. All right, Chelyabinsk. They had a little trouble at first finding it. It took them a while, and eventually, look at this. They find this huge hole in the local pond, and they broke it on the way out, but it turned out to be a rock about the size of a coffee table. That's the biggest piece they found of Chelyabinsk. Lots of interesting stuff here. Hope you'll research it more. Thanks for listening.